All right, have you ever looked at a math problem and seen the variable you need to solve for, like x, stuck way up in an exponent? It looks impossible, right? Well, today we're going to tackle that exact problem and break it down into really simple, logical steps.
Okay, so here's our challenge. Our whole mission is to solve for x. But look where it is. It's not down on the ground floor with the other numbers. It's trapped up in the exponent. So the big question is, how in the world do we get it down from there? So first things first, we got to know what we're looking at. This is called an exponential equation. And well, the name kind of gives it away, doesn't it? It's an exponential equation because the variable we're trying to find is in the exponent. And this is the big trigger. The moment you see that variable up in the exponent, a little alarm should go off in your brain, and that alarm should be screaming one word: logarithms. That is the special tool we need for this specific job.
So why logarithms? What makes them the perfect tool for this? Well, it's because exponential functions and logarithmic functions are inverses of each other. They're basically designed to cancel each other out.
And this slide right here shows that relationship perfectly. They're like two sides of the same coin. They're just different ways of writing the exact same idea. And this inverse relationship is precisely what we need to free our variable.
Okay, so when you actually go to do this, you'll grab your calculator and you're going to see two main buttons for this stuff: log and ln. Here's the good news. For a problem like this, it literally doesn't matter which one you use. You'll get the same answer. It's really common to use ln, the natural log, so that's what we're going to use here.
Now this brings us to the single most important property of logarithms for what we're doing. I want you to think of this less like a rule and more like a superpower. It's the key that unlocks the whole thing.
And here it is, the power property. This thing is an absolute game changer. It basically gives you permission to reach into a logarithm, grab the entire exponent, and just pull it right down to the front. And just like that, it's not a scary exponent anymore. It's just a regular number you can work with.
So check this out. It's like a magic trick. You start with the log of our term. And then, using the property, poof, the entire 2 minus 5x expression drops right down to the front. It goes from being an exponent to just being a simple multiplier. That is the whole trick. It's the one move that makes these problems solvable. All right, let's recap. We've got the problem, we've got our tool, the logarithm, and we know the magic trick, the power property. Now let's put it all together and just walk through the solution, one step at a time. Okay, first move. The golden rule of algebra is whatever you do to one side of the equation, you have to do to the other to keep it balanced. So we're going to take the natural log of the entire left side and the natural log of the entire right side. Simple as that. And now for the main event. This is where the magic happens. We immediately use that power property we were just talking about. That 2 minus 5x is no longer an exponent. Look at it. It's down in front, just multiplying the ln of 3. The variable is free.
Okay, a quick but really important point. Don't get intimidated by how ln of 3 and ln of 11 look. I know they seem complicated, but they're just numbers. Seriously, they're just kind of messy decimals, like pi. If you type them into your calculator, it would just spit out a number. So for now, just treat them like any other number.
You know what? From here on out, this is just a normal algebra problem. We're back in familiar territory. Our goal is to isolate x. So to get that part in the parentheses by itself, we need to get rid of the ln of 3. Since it's multiplying, we do the opposite. We divide both sides by ln of 3. We're getting really close now. The next logical step is to deal with that 2. It's being added, so we just subtract 2 from both sides of the equation. And for the final move, x is being multiplied by -5. To get it completely alone, we just divide the entire right side of the equation by -5. And there we have it. We've successfully isolated x. The equation is solved.
So we have our answer, but it's really important to know that there are actually two different ways to write it down. And depending on the situation, you might be asked for one or the other.
On the left, you've got what's called the exact answer. This is the answer before you touch a calculator. It uses the logarithms themselves, so there's no rounding, which means it's 100% precise. On the right, you have the decimal approximation. That's what you get after you finally punch everything into a calculator. And what does that decimal look like for our problem? Well, after you do all the calculations, the final answer for x is approximately -0.036. So what's the big takeaway here? It's this one simple but super powerful idea. If you see an exponential equation, your brain needs to immediately think logarithms. They are the perfect tool for the job.
They were made for each other.
Thanks for watching. Now that you have this technique in your back pocket, you're ready to solve a whole new class of problems that might have seemed totally impossible before. Happy solving!